In 2010 and 2011, the Town of Payson conducted important tests and research in preparation for treating the water that would be coming down from the Cragin Reservoir. A pilot treatment plant was set up at the power plant site to test the Cragin raw water and determine what would be needed to purify it for use in Payson's existing water system.
The pilot test was really important to the project. First of all, the CC Cragin water is a really good quality water, and initial analysis told us we just had to do TOC removal, aluminum removal, and iron removal. And we started out with just the PAL membrane, the membrane filtration, and the hope was that's all we'd need. But when we ran that with the pilot test, we found that it did great for aluminum, great for iron. It didn't remove the total organic carbon. We add a chemical to it, a polymer, and it causes all those little TOC particles to bind together so the filter can remove it. And we did that, and after that, we were actually below the limit on TOC that we wanted to get to, but just barely. And so because water quality can change, especially in a lake, we didn't want to rest on that. And so we ended up adding a polishing step, which was granular activated carbon, and it also helped remove TOC. And so when we piloted all three of those together, we were able to get non-detect for aluminum, non-detect for iron, and non-detect for total organic carbon.
The water would also have to be buffered because the new surface water is entering a groundwater system where the groundwater has been in contact with underground minerals and deposits and would have a tendency over time to harm the existing system.
The well water is it's a harder water, it has high alkalinity. The CC Cragin water is actually a very soft water, it has a very low alkalinity. We did some chemistry adjustment to our water where we added alkalinity to it and we adjust the pH. And so we actually get a net neutral water that's not going to deposit on the piping, but it's also not going to dissolve any minerals. So that neutral water makes it so our water is not going to have an impact on the piping system or the wells.
We had the contractor, which is J&L Excavating, which is a local contractor. They came out and started the excavation for all the piping underground before we started building the building. And they found rock and hammered through it. And it was pretty slow going most of the time, and it slowed them down a little bit. These are the deepest points in the project. This will be the town distribution line for the treated water and the completed water. It runs this way and then toward the town. This line here is just a pond line that between these two lines are the deepest. They'll be underneath the main entrance. We had to start here due to the fact that we have to start at the bottom with the hard rock and work our way up.
On the 7-acre side of the water treatment plant, there is so many equipment, buildings, and structures, and hydroelectric generators, and water treatment facilities, and tanks that had to be built on a small site and had to all be connected with pipes. Well, it wasn't just one run of pipes. Sometimes a big pipeline would have to go to the tank, back from the tank to another building, to another tank. So you actually ended up with tanks, various pipelines occupying different levels within the ground. So you'd put the deepest one in first at maybe 15 feet, and then the next one would be at 12 feet, 10 feet, 6 feet to accommodate all these intersections of pipes.
As we know, Payson has rock when you get a couple feet below the ground. And if you walk the site, you'll see that some of the alignments of the path of water isn't actually the most straightforward path. And that's for two reasons. Well, two things we're really going for out on the site. One is gravity flow. We want to do much of the water movement by gravity because pumps are expensive, operation and maintenance and cost and all that stuff. But we also wanted to reduce the amount of rock we had to dig into.
The surveyors are here today, and they're over there in the back, and they're actually checking the line that's going from the hydro building to the surface water tank. Coming out of the hydro building, there needs to be a straight shot coming out of the turbines to allow the water to flow, and then it'll hit the grade, and that's what they're out here doing today, is to assure that we have that flat flow and then the grade downhill to the surface water tank. After we got most of the piping in the ground, the contractor decided that they would start on the clarifier.
The recovery clarifier, where we have the backwash water
that comes out of the filters. It goes into this basin and it separates out the clean water from the sludge. The clean water then gets recycled back to the beginning of the treatment plant to go through the process, and then the sludge layer in the bottom goes to waste. And with this, we recover about 90% of our water.
So they started on the clarifier, then went to the FEQ, which is for flow equalization.
FEQ, or flow equalization, is the process of mitigating changes in flow rate through a portion of a water system by providing storage to hold water when it is arriving too rapidly and to supply additional water when it is arriving less rapidly than desired.
Following the FEQ, they started on the surface water tank and flock, which is flocculation. Now that originally was set to be two different tanks, two separate tanks, with a flow meter vault in between the two tanks. To reduce our footprint on the site and make things easier, engineering combined those two tanks as one tank. That in itself, once again, saved a lot of money because you only had to excavate once, you only had to pour your sections once, you didn't have to build two tanks, two floors, all those types of things.
So this is the raw water and flocculation basin, where on my right hand side we have raw water storage, which acts as a shock absorber in case we have to close valves or anything. And it's divided by a wall, and on the left side is the flocculation basin. And what that does is it takes all the little bitty particles in the water, brings them together and forms bigger clumps that can be filtered out in the process.
So following that, they went over and they did the main lift station. The lift station, the pumps will be on that end. This will be the holding tank, and it will stick probably 3 to 4 feet up out of the ground. And of course, all the concrete will be color matched to the surrounding.
This is the main lift station. It's where all of the waste from our treatment process goes. Water gets neutralized in this basin, and it either goes back to the clarifier where we reuse 90% of the water, or it gets sent from here to the local golf course.
After the clarifier, we did the FEQ, and then we went to the surface water flock, then we went over to the main lift station, then we came back up to the hydro generator building. And the reason why I basically went in that order is because the building order, because of the change in design early on of block to steel, that kind of dictated when we were able to start on the hydro building. When we did the hydro building, they put in the conduit and all that prior to them backfilling the inside. So basically what you have is you have a false backfilled area underneath the slab floor that contains all your electrical conduits and everything like that. All the piping that was put underneath, it was poured solid with encasement on each piece. So there's nothing underneath the building that actually moves. It's the building moves or nothing moves. And that's a good thing because we have the turbine in there that generates power for the plant, which is, from my knowledge, is supposed to pay for itself within 10 to 15 years and to be self-sustaining. So that's a plus for this site, to be able to generate their own power for usage and rely very minimally on the power company up here.
So what you see behind me is a 500,000 gallon finished water tank. It is the fourth of 5 concrete structures to be constructed for this project. It's very important that this one is completed because it occupies a lot of space during construction, and now that when it'll be completed within 2 weeks, we'll be able to start backfilling all the ditches around it. We'll have more clear space to work on the site. We can start constructing the site road, and other activities that can't be done while the tank's under construction.
The treated water tank was actually done by a subcontractor, which did not affect the building of the main treatment building, hydro building, or any of the peripheral items. They came in and did with their own crews, did all their work, and they were a subcontractor to MGC. That was a Type 3 tank. It was poured modularly with wall panels, and then you tilt the wall panels in place, and then you pour the gaps in between. We require the concrete to have certain slumps. The lower the slump, the thicker it is, the less it runs. The higher the slump, the more runny it is. So we were trying to hold them down around 4, 3.5 in that realm. The concrete, nice and solid for placement. It's not cemented in with anchors, rebar. It's spiral around with wire to hold the structure together.
It's a seismic reservoir. It's able to withstand if there's a small earthquake. And stress seal, actually what it does is it compresses the concrete inward, and that's the wrap that goes around it. And then they got to cover it with shotcrete. This big site here is the actual membrane building, where it'll go through the filtration system and the process of getting the water treated. And you can kind of see what the excavation consists of. After 2.5 foot, you got nothing but rock.
You got to have your underground in place to have your pipes come out through the floor. You've got to have your electrical conduit in place so it gets buried underneath the concrete in the floor. So all these things need to be done before you can start on your building. The town wanted to reduce their construction cost. And so the building got changed and put in, which led to a lot of engineering changes.
During the value engineering process, the contractor came back with an idea to save some money to change from a block building to a steel building, and with that there was everything within the building had to be revised.
When you go to a steel building, you have more 90-degree angles instead of 45, so it's more of a box now, and so that made some of our rooms get a little bit bigger, which wasn't that big of a deal, but we did adjust some of the equipment a little bit just to better utilize the space.
And when you change a building from a block to a steel building, now you have calculations you have to consider for hanging your pipe, installing all your piping, your material, your gear, your pumps, and so on.
You have 16 different pumps and other items that move water in different directions. Each one of those has to be powered, controlled, and monitored, which all has to be separately wired. So it gets to be a long task to get everything done. Going to the metal building is actually a lot cheaper, and any of the time changes were not directly reflective of the building.
This project has been going on for a while. I personally have been working on it for 8 years. And we have electrical guys, we have structural guys, EITs, CADs, people doing drainage. I mean, there is a whole lot that goes on to make this happen. I mean, the treatment process is only actually one aspect of it. You got so much more that goes into a site like this to make it work. And so it was definitely a team effort, and a lot of people at Sunrise put in a lot of hard hours on this project.
This is a very unique project with having the surface water, needing the water treatment plant, which the town never had a need for a water treatment plant before, having a hydro facility that used some of the excess pressure from the pipeline coming down from such a high elevation, and all the treatment processes going on here just made it like 5 different projects in one.
This is a great project. This is a special project. It's very unique. I don't know anyone else in Arizona anyways that has a hydro generator that helps power the treatment plant. I've given multiple presentations on this project and everyone always says, wow, this is just a unique situation. We're taking water from 23 miles away. We're having to cooperate with SRP for them to do part of the work for us. We're then picking it up, crossing Forest Service lands, yeah, like the hydro generator, and then the ASR wells to be able to inject this water back into the ground, the water we don't need. Like it's a great project.
Being a local resident here since 1991, I'm very proud of this project and proud of Sunrise Engineering, and we're really honored that we were part of the team that made this happen and actually gave the town a sustainable water source for the future.
This has definitely been the toughest job I've ever been involved with. It's just a pleasure to have the team that we were working with.
I've been asked, when is Payson going to get tours? And I know a lot of people want to come tour this plant.